Now let's take a look at some of the programs that we have to debug, because there are some things that are not quite right with them. So let's take a look. So I believe it is in my folder. It's I think I called it lec16-3.c. Yes, I think that's right. Okay, so let's gcc -o lec16-3.3 lec16-3.c. Okay, let's run it. Okay, so I call the output file lec16-3. I'm going to run it by saying /lec16-3. Okay, so it says the sum from 1 to 5. So what it's supposed to do is add up numbers from 1 to 5 and gives us this wrong result. So let's take a look. You know now that to be able to use the debugger, which is what we should do next, we have to use the -g switch or the -g flag, and that should enable us to run GDB on this lec16-3. So when you run GDB, you don't need the /, but when you run it at the command prompt, you're telling bash in the current folder, in the current directory, there should be a file named lec16-3, and so run that. Otherwise, if you did not have that, let's just do that. So if you did not have that, you would say lec16-3 or whatever output file name that you created. It'll say command not found because it's bash is looking for commands in the usual places, quote unquote usual places, where it expects to find commands. The current directory is not one of those places, and you can make the current directory be one of the places that bash always looks for commands, but that is not a good idea because that is considered to be a security hole. So that's really why we end up having to do this /, like whatever file you created, executable file. One thing to note is that if you run this a few times, you will get, besides the fact that it's obviously wrong, you'll get a different result each time. Whenever you see that, you want to think, oh, so that's probably because I have some variable that was not initialized properly, so that if you try to read a variable that was not initialized properly, you're reading something from some location in memory. Who knows, depends on what ran just before in that memory location. So you can never see anything. You might see something consistent every once in a while, but still wrong, and that's also possible. So it's possible that you might get, for example, just this same number every single time you run the program. Yeah, that is possible. But and so if that's the case, then you might think, oh, there's something really wrong with my program, and you'd have to debug it. This gives us a hint that, oh, okay. It is kind of odd. I am kind of surprised that it's numbers within a range. So it doesn't go like from -10 to something. It's always seems to be sticking in this range. So you can't really tell why that is. Okay, so now let's GDB, and you can say /, but you don't need it. You can just go ahead and call it the file name because that's where GDB is going to look. Okay, let's list, and list again, and we see the entire file. Okay, so now let's try to set a breakpoint. Let's say break at line 9 and run it. Okay, so right now here we are at line 9. We're just about to go into the for loop, and let's just take a look. Let's see what I is. I is not such a big deal because we are going to initialize it in the for loop. So we know it'll be some random value. Because we have not executed this I equals 5 yet, so we're just about to. If you're at line 9, we're about to execute this first thing in the for loop, but we haven't yet. So in this case, I just happens to be this 32,000 number. Now let's print sum. Okay, so there we see right away the problem. Sum is some large number. Okay. Let's see if we can set sum to 0. And I actually forgot the way to do that. Let's see if that works. P sum is 0. So you can do things like this. You can set values. I just happened to luck out. I didn't remember what it was, but set sum equals 0 seems to be working. We'll try it out. Oops. I keep typing ls instead of list. Okay, so there it is. So now here's something you can do. You can use the display. You can display I and sum. Okay. And it seems to be saying they're both 0. No, I don't think that's right. Display I. Okay. I is that, and sum should be 0. So now, let's do a next. I could have done an n, but okay. So here, oh, so because I thought this would work, but it didn't. It's giving me an I comma. So whatever. So I is 5 at this point. So first time through this for loop, if you're at line 10. I will have been initialized to 5, and so at this point I is 5. Sum will have been a strange arbitrary value, but we set sum to 0, and that's why sum is equal to 0 now. So we're going to check and see if this works. Let's do n for next, and at this point sum got I added to it. And so sum is 5, and so let's skip over the 4. At this point we decremented I, that's from here, and so I is 4, sum is 5, we add 4 to sum, then we add 3, then we add the 2, then we add the 1, and this time around I think, oh yeah, we got to return, sorry, we got to return. And at that point I was 1, sum was 14. That's not exactly right, but we're closer than before. So you want to see how you can fix that. So it's, let me see if I can figure out how to I can't figure out how to undisplay something. So help display. Oh, use undisplay. Alright. So let's do undisplay I comma sum. Alright, so we got into that strange mode, and now I don't know if we can get out of it. So best thing to do might be to quit it and then run it again. Okay, so this time around we list it. You see the whole thing. We'll break at line 9. We run. We print sum, we get this strange value. We set sum equal to 0, and then we display I and display sum. We cannot do it both on one display command, I guess. Just messes up. Okay. So now we can continue. And it says the sum from 1 to 5 is 14. Let's see if we can figure out why that is. So take a close look at this loop. This is all you have. It's just these two statements that you have to worry about. We start from I equals 5. We go into the loop and I does have the value 5. And you want to think about it, well, if you want to sum from 1 to 5, is this the right thing to use? So chances are you can try something else, like say greater than or equal to, for example, and see if that works any better. Also, the other thing, of course, the main thing really is you want to initialize these things. You don't need to initialize the I. Before we go, let me just point out one thing. So if we were to look inside this program, and you might say, well, why do we need this? Can't we just comment that out or delete it and say int? Well, this works on some compilers, but unfortunately it does not work on all C compilers. So that's why we have to have the I declared before the for loop. So I'm going to quit out of here. I'm going to say gcc, whatever gcc command I had, and you get this error message saying for loop initialization declaration used outside C99 mode. So for standard C and CC99, I believe that would work. And so if you were to figure out using man gcc how to use, I believe, C99 mode, you might be okay. I'm just going to search for C99. So I believe if you use GNU99, alright, so let's try that real fast. I think you have to use -std equals. -std equals C99. Let's try that really fast. -std equals C99. Yep. So if you use the C99 standard, then you can use an int I. So when you do 16-3.c, if you want to use this, if you're really sure you want to use this, remember to use the compile option -std standard equals C99, and then everything works. This is, I would recommend this, although in all the programs that we see, I will stick to this older convention. Why? Just because there are still quite a few systems where they expect the C90 to be standard. Okay. So good luck debugging some of these other programs.